all have listened about mechanical engineering, maybe Vortex, and why not even MMA?
Yes.
But how does it really work or affect our lives? Today, Dr. Binyet and we both are gonna make the science behind it edible for everybody. Así que toma pulque y come nopal, que el Pulche Podcast va a comenzar. It's my pleasure to welcome to this space Dr. Binyet. Dr. Binyet.
Please call me Emmanuel or Manu.
Manu.
Yeah,
okay, I'm
better.
gonna call you Manu.
Thank you.
How are you, Manu?
I'm good. Thanks for having me. It's an honor.
No, it's an honor for me. As you can see, I bring my UFC shirt with Glyconega, big friend.
Yeah, nice.
So
beautiful shirt.
Yeah, I was just talking with you about how is it that you are an MMA fighter? When did it begin?
No,
interesting.
No, it's just like you. I started martial arts as a kid, as a little kid when I was 8 years old.
Yeah.
And the thing is, I did judo as a kid.
By your own choice?
My parents put me there because my parents were training as well.
Oh, okay.
Yeah.
Oh, that's awesome.
So they put me because I had too much energy,
Yeah.
So I would go training every day as a kid, and I loved it so much. And the thing, I was always rules, I couldn't stand the rules. The rules were stupid, I was but there's no score because the guy lands on his chest. Why not?
Yeah.
Why does he have to land on his back for a score? If he lands on the ground and I was I could hit him now. Why I cannot hit him? Well, it doesn't make any sense,
Yeah.
right? So I always had problems with each martial art. They have very specific rules.
Yeah.
So they develop skills made for those rules, that it wouldn't work in a fight. And so I fell in love with MMA because it was the most open, there's less rules, so it's more realistic. So you only keep stuff that really work,
It would be the perfect mixture of all of them.
Yes,
right?
exactly. It's the perfect mixture of all of them. There's no room for bullshit,
Yeah.
And because a lot of martial arts, they care more about the beauty of the moves,
Yeah.
the beauty of the move, that's a beautiful score, it's a beautiful technique. But MMA is more about efficiency, It's not about beauty that much. It's about more this is efficient. And that's the thing I like with MMA is any position, as long as you can do damage, is a good position, right?
Yeah.
Recently we have seen knockouts from the bottom, stuff you would never see before. The guy on the ground.
Oh yeah, and the other one is standing.
Yeah, and he just hits him from the bottom, from the bottom position.
Yeah.
Who said
with the ankle, right? Have you seen those type of?
Yeah, okay, yeah. But those are
sick.
Those are sick. Yeah, exactly. So you need to control the guy, right?
Yeah.
Even when he's on the ground. And recently, there's one. The guy was on the ground. Just hit him with hammer fist and knocked him out, right?
Yeah.
Or just stood up and just hit him. So that's the thing I like with MMA is it doesn't matter the position as long as you can do damage. It's a good position. So it's more about efficiency, about real efficiency. But the problem with MMA is the damage.
Yeah.
It's you take too much damage when you do MMA. So
yeah, I was gonna ask you that. What is your preparation for it? How do you prepare for this damage, and how do you prepare for a fight?
No, so the thing about MMA is you have to train you have to train every day. You have to train so many skills, right? You told me you did BJJ, boxing, taekwondo, karate, all this stuff, right? So you have to train all these skills, you need wrestling, you need kickboxing, you need ground game, and then you need MMA specific stuff fighting against the cage, transition to ground game with strikes, wrestling with the strikes, how to mix up
wrestling with strikes.
Yeah, how to mix up your striking and your wrestling, so there's so much skills you have to work on, and then you need strength and conditioning training.
Yeah.
So you have to at least you have to train every day for sure, and as much as you can, because the thing with MMA is in other sports, when you lose, you just lose. You say, oh, I just lost, it's too bad. But in MMA, if you lose, you get your ass kicked. So
and it can be both ways. Like you are performing awesome, you are giving shots and things like
Yeah.
that. And then you receive, many people call it lucky shots.
Yes.
But
Yes.
you receive a good shot and
you're out.
You out.
Yes.
Maybe
Exactly.
you were it was a 5 rounds
Yeah.
fight. You were winning 4 rounds.
Yeah.
If the 5th one you get KO'd,
You get killed. You're out. It's
you
finished.
lost.
Yeah. So because of the small gloves, like you have to be like so careful all the time. Yeah. No, I mean I think it's the hardest sport for sure.
Yeah.
Because the thing is, when you lose bad, and only the referee can save you.
How? Yeah, that's right.
You know what I mean? Like the guy, like that's the thing.
You are down there being knocked out.
Yeah.
The only person that is gonna stop that other guy is gonna be the referee.
Yeah. So you have to put your trust on the referee.
Yeah.
Sometimes it's hard to do, you know. But yeah. So that's the thing about MMA is like the consequences are like dear, you know, like you. Yeah. So you have to train a lot for sure.
Yeah.
So that's what I would say is like just you have to train a lot, and it's hard because you have a life. You need
that's right.
you need a maybe you have a job, you have a career, you have a family, and you have to put all the training, like you have to fit all that training in your daily routine, you know.
Yeah.
So that's the hard part of MMA. That's the hard, you know. It's like because the thing with MMA is like you have to train a lot, otherwise it's dangerous.
Yeah.
Right. If you so it's kind of a lot of pressure. Yeah.
Manu, may I ask you, how do you take both victories and losses? How do you take them?
Okay, so there's one thing, like when you compete MMA, you cannot care too much about losing.
Yeah.
You know, because it's like if you care, then you cannot go fight. It's like I think the most important is like to showcase your skills, to perform, you know, to show what you can do. And because, you know, like may the best man win. It's a sport, you know. If the guy is better, then he should win.
Yeah.
Right? So like if the guy is better than you, then he should win. So like it's you don't have to think too much about winning and losing because there's 2 guys in the cage, there's gonna be 1 winner, 1 loser. So yeah. But the problem is like the society, how it works now, when you win, like people,
Everybody's clapping.
yeah, and then they forget losers like right away, right?
Yeah,
If you lose, then you're forgotten. Like you've seen great champions, like they were like champions for years, you know, like nobody could, and then they get beat, and then a few weeks, a few months, and they're forgotten. People just forget about them.
Yeah.
So yeah, that's why people care too much. But I think it's more about like if you do martial arts, it's more about skills, about showing your skills, you know.
Yeah.
Yeah, less than victory, you know.
And may I ask, how do you do what do you do once you win something and once you lose something? What are, like, let's say, what is your ritual? Like, okay, I win, I'm gonna go eating. We were just saying, like, you usually walk in I don't know what weight, but you fight in a lighter weight.
Of course.
So what do you do?
Okay, so first thing I have to say is like why people do that, because it's the strength. They want to have strength advantage.
Yeah.
They always want to have more strength than the other guy. So the strategy is like to start from a higher weight class to shrink down, you know, to a lower one. So you feel stronger. So like, yeah, you diet and then you weight cut. So after weeks of diet, of course you want to eat.
Yeah.
So yeah, for sure, like eating good food, like enjoying good food, that's one thing. Yeah. And like so much training, like you're just so sick of training, you know. So usually after a win, what you do is just like you just have fun, just relax, just do stuff that you didn't get to do, you know. And then you're just happy, you know, like you have this happiness, like it's like because you train so hard and you have like so much pressure to step in the cage, you know, fighting in front of people, and then you win, and it's like you have this huge like discharge of like happiness. You feel so good, you know what I mean? Like you feel high, like really, it's like it's unbelievable how much like endorphins you get, you know, and people get hooked to that. That's why you see like so many fighters they cannot retire.
Oh yeah.
Yeah, because you get hooked to that feeling, you know, like because like it's
of
like
the after fight.
Yes, because it's so much pressure, and then that release that when you win, you know, like, and also like people praise you, you know, and so you get like so much so much of it, and it's like it's addictive. It's like a drug.
Yeah. That's why we're having Mike Tyson coming back to the rings.
Exactly. That's what I mean.
I want to feel that.
Yeah, it's like a drug. People get hooked on that. I mean, so the problem is like some people should retire, should stop fighting, but they keep fighting because they can't. So, and I think a lot depends on people's mindset.
Yeah.
You know, like of course it sucks because like a lot of people help you, and then you lose, so you feel like you let down like everybody that is helping you.
Yeah.
You feel like letting down the whole team, you know, everybody that supports you. But that's how you feel when you lose. So you feel sad. And like some fights is like if you lose like badly, people use this the video, they use the image, the pictures, and like you're like, man, people just make fun of you.
Yeah.
And
all
so
the memes.
The memes is so.
Do you have any memes?
No, I'm not famous, so I'm lucky, I guess.
You are.
No, but what I'm saying is like, that's when you lose badly is like, that's what you're scared of. Like, you're like, shit, I hope I don't end up being a meme, you know? Because like you see those UFC memes, some are so mean.
Of course, when they are like sleeping, then they put it sleeping and I don't know where else.
Yeah.
Things like that.
And then you just hope that people get tired of it. And
yeah.
But that means just don't. They don't get tired of it. Like the worst meme was like, I think Ben Askren when he lost to Masvidal.
Of course.
This KO, like, after years, you know, like,
and everybody's still telling him like, "Oh, you were going to sleep."
Yeah, it's been how many?
days.
It's been like years and stuff, you know, like, yeah. So that's what you're scared of, you know, like, when you lose, you're scared a bit, but you cannot care too much. It's like a show, anyways.
But I mean, you know, right now, like you see a meme, and you might be like, "Oh, this is too bad," because you've been in that situation.
Yeah, because I've been there.
So the people that keep laughing and keep like showing like, "Oh, look at this," it's like because they've never been.
They've never been there. They don't know what it means.
Right?
Yeah, I got knocked out one time. Like MMA, I have pro MMA. I have 3-1 loss.
Yeah.
And the only loss I got, I was just like that fight. I just hit with one punch. I mean,
you connected one punch.
I got knocked out. It's one punch, and I get knocked out. And then he hit me on the ground, but I wasn't conscious, so I don't even know. I had to watch the video too, and I was sleeping on the ground.
I saw it. But
no, you saw it. You saw it. No, yeah, you see, like, and like.
Yeah, my brother.
And that's the problem is like when I tell people, I do MMA, and that's the first video they see. It's like me sleeping on the ground. And then I remember like there was this reporter. They say, they wanted to make an article about me, a paper, because I was a student, I was training, and I was fighting MMA. So they interviewed me and stuff, and then they filmed me, and then they came to the fight. And he said, we're going to take some pictures while you fight. And I was like, yeah, sure. And I lost so bad, right? And then, so I got knocked out. And then what happened is like, they tell me, we use the picture. I hope you don't mind. I was like, no, sure. But I don't care because I come to fight. I win, I lose. It's part of the thing, you know, I don't care. But then I saw the picture. I had like my eyes, rolled over. I was like this. I looked dead. On the ground, that's the picture they used, like for the article. I looked dead on the ground.
You mean for the
article? They wrote a newspaper article, yeah. And that's the picture they used. And I was like, what?
Did you tell them?
Yeah, no, but it was out. It was already published, and I was like, that's what I mean, right? So,
did you saw that picture before?
No, I haven't. They just published the article because it's reporters, So when this picture is like people gonna buy the paper when they see that picture, it sells. So that's the thing.
Yeah, it sells.
Yeah. So you cannot care too much about like you cannot be too proud. If you're too proud, you cannot fight.
Yeah.
You cannot compete because like
you can stick to it.
Yeah. Yeah, like the thing is you have to let go, it's part of the thing. Sometimes you win and sometimes you lose, and when you lose they can use your image. And when you fight, you compete, you already agree with that. You already know that that may happen, but it's part of the journey, like this is like this is the highest level of martial arts is MMA, you know, professional MMA.
I just remember like the picture of Conor McGregor when he's sleeping.
Yeah,
everybody have used that one.
Yes,
so I just remember
it was so
like,
funny.
Oh, that's so bad.
With his head like this.
Yeah, with his head like
yeah, it's so funny, right?
Yeah.
They use it like everywhere.
Yeah, but Manu, how long time have you been an MMA fighter?
MMA, like when I started fighting,
like professionally. Let's talk.
Professionally.
You have 4 fights?
Yeah, only 4 because it's hard to get fights. To be honest,
no,
it's very hard.
Right now we are in a pandemic, and you got 2.
Oh
right?
no, pandemic is so bad. No, I didn't fight since 2019.
Oh,
yeah, it's been 2 years I haven't fought because of
I thought
the pandemic.
That your fight was very close to.
No. I haven't fought like because of the pandemic, and it's kind of hard to get fights. Yeah. Like because you need like you need a good team, you need a manager to push. You know, it's.
Yeah, that's right.
Like because when you fight for small organization, you get one fight here, one fight there. It's kind of hard, you know. Like, but I only like professional fight only 4. Yeah. Yeah, but I started like 2016. Yeah. 2016.
Yeah. So
no, I wish
I did 4 fights in 3 years.
Yeah, that's
okay.
Yeah, I wish I'd done more.
How long is your preparation time
for one fight?
Yeah, the one that you take.
No, like I don't do fight camps and stuff because, like I said, it's like I have like a normal life, you know, like you know when you try to.
You are a PhD.
Yeah.
So.
Yeah, so like you need. I think. It's about balance, you know.
Yeah.
Like MMA is a hobby, it's something I love.
That's
but
great.
I love science so much, you know. Like since I'm a kid, I love school, I love science since I'm a kid, and I love sports and training. So I believe that I can find a balance between the two, you know. Like that's how I pursue happiness, you know. Like having a balanced life. So. I don't do training camps. I try to train as much as possible every day.
Yeah.
And then, so when there's a fight, I train a little bit more. When there's no fight, I train a little bit less.
Okay.
That's it.
But you're always training.
Always, yeah. Yeah.
And Manu, where did you grow up?
Okay, so I'm from Switzerland, Geneva.
Yeah.
My father came from Cameroon as a student, like in the 80s.
Yeah.
Yeah.
Nganu.
Yeah. Ngannou. Oh, this is amazing. His story is amazing. Like I knew about Ngannou like very, very long time ago.
Doing mining, something like that, right?
Okay. So, yeah, he did a lot of jobs, like because he was like a illegal immigrant, right?
Yeah.
So his story is crazy, and I heard about him like long time ago before he was famous. You know, when he started fighting.
Yeah.
Yeah, and then he became a champion, and so it's like a movie, you know, because he came like from the lowest of the low, like being a illegal immigrant, you know, like it's so tough, the route to Europe, like they cross the desert, you know, and
I don't know.
It's like
he crossed the Sahara.
Yes, they cross the desert, and then they from Libya they go to they cross the Mediterranean Sea to Italy, you know, and then from Italy then they go to Europe. And
you just said that your dad is also from Cameroon.
Yeah,
did that too?
No, of course not. No, he came as a student in the 80s.
Just asking.
No. He came as a student in the 80s. Like like I mean, but the thing is like, what is sad is like people. It's like slavery there, like these illegal like immigrants crossing the it's like slavery. It's so bad what happens to them. Like they get murdered, they get raped, they get like kidnapped and tortured for money, you know. Like it's so bad what happens to these people, and like
I really can't imagine, because maybe some Latinos have that.
Too, similar.
To
the US
States.
Yes,
but
similar.
Only like at least because it's the US, you have more cameras, right?
Oh yeah.
And maybe in Africa, when they crossing, like I just said, the desert and all of that, there are no cameras recording.
Oh, it's horrible. Right? So many people die.
Yeah.
No, it's sad.
So this is your dad is from Cameroon.
Yeah.
And how about your mom?
She's Swiss.
Yeah. Oh, okay. So you grew up in Switzerland?
Yeah, in the countryside near Geneva.
Oh.
Yeah.
And where did you study? University?
Yeah, so I did engineering school in Geneva.
Yeah.
So mechanical engineering.
What did you focus on?
Oh, so I really love fluid mechanics.
Fluid mechanics, yeah.
Yeah, so when I was doing a bachelor's degree, I really loved fluid mechanics, and I did my bachelor's thesis on a system we would use the water of the lake to do air conditioning.
Okay.
Yeah, so
how would it work?
No, it's like you can use like because like they have like Geneva, it's a huge lake. There are a lot of buildings along the lake.
Yeah.
You just pump the water from the lake. You use it like to do cooling. So in the summer you can do cooling, and then you reject that water like because it absorbs heat, right?
Yeah.
So it's a little bit hotter than the lake, and then the problem is like when you inject hot water in a live body of water, like a lake, they disturbs the ecosystem,
Oh,
because
okay.
of the temperature
Different
difference. Yes, so the fish, they think that the water is warmer, then we can lay eggs and stuff. So they lay eggs because the spring is coming, right? The thing is, but then but it's actually not true. It's just this region where the water is hot.
Yeah.
When you reject the hot water, and then what happens with the current? Then when the water cools down, the eggs die, right?
Yeah, of course.
So it's bad for the ecosystem, also for algae and so that's the thing when you have like a different, it's pollution, thermal pollution. It's called thermal pollution. Yeah. So I was focusing on designing like
a type of cooling.
No. I was focusing on the thermal reject when the hot water, how to mix it with the lake water. So use like turbulence to mix it, because when turbulence is you get better mixing with more turbulence.
The temperature would be more even all around the lake.
Exactly. So that was to reduce thermal pollution, and then when I did that, I just loved fluid mechanics when I was doing my bachelor's degree. And then I worked for a while, and then I was like, no, I want to go study abroad. I want to do something different. And
then you went to China.
I went to China because
did you learn? I wanted to. Anyways, your Chinese is awesome. But,
thank you.
So I would like to ask you, did you learn Chinese before?
Yeah. So like, I was like, no, I want to do something completely different. I want to go somewhere like completely new. I was not interested in going to any other Western countries, because like Swiss people, like Switzerland is a beautiful country, but like young people are kind of bored. They want to go, like, I have so many friends, they went like to all the corners of the world. I even have one friend, he toured the whole world. Yeah, like Swiss people love traveling. Yeah, the whole world. Swiss people love traveling so much.
Once you have the money, you
That's true. Yeah, that's true. Swiss people love traveling. They love traveling. So like everybody goes studying somewhere else. I have like my neighbors. I went to Canada, USA, Australia, whatever. And then I was like, no. I want to do something different. I want to go to Asia.
Yeah.
And then I was talking to a friend. So I had a friend who went to Japan. I was like, no. I want to go to China, because as a kid, you grow up watching kung fu movies and stuff, and they're like.
And you said that you were practicing since a kid.
Yes, as a kid, I was like, no, I want to go to China. It's more fun, And China is like it's expanding so fast. I was like, it's interesting to go to a country that is like has this huge expansion, because
it's developing.
Yeah, it's developing.
When was it?
Oh, it was a long time ago. I'm shy to tell you, otherwise you know my age,
Oh, no, then don't say it. That's a long time ago.
Yeah, a long time ago.
China was starting to develop.
Not that bad. But,
no. You still met Mao.
Exactly. No. But the thing is, and I was like, no, I want to go to China. So I met some Chinese people there in Switzerland. I was like, I want to go to China. So there was like this forum where you can like exchange language and stuff.
Oh, okay, yeah.
Yeah, so you can like trade off. Like I teach you some French.
Yeah.
Or you teach me some Chinese. So I started like
in Geneva.
Yes, I started learning Chinese, right? And I loved learning Chinese. It was so much fun, writing the characters and everything.
Yeah, all the story behind them.
Yeah, it was so interesting. I was like, wow,
all this is science behind them.
Yeah, exactly, And like, I was like, wow, it's so interesting. And then, so while I was working, I was studying Chinese, and then I got a scholarship China's government, because they were giving scholarships to foreigners because they want foreigners to come. You know, they want this cultural exchange. So they were giving a lot of scholarships. So I had a scholarship to go to China to learn Chinese for a year, do like a language year, and then do my degree, right? So I did my master's degree in China. So like I learned.
Was it in Chinese or in
English? It was in Chinese. That was so tough. The first exam I had, you cannot imagine. Like an exam, like the exam is in Chinese. So but the books were in Chinese, the classes were in Chinese, the exams was everything was. I had to write Chinese for my exam. And you know how you write Chinese? You write so slow, right?
Slowly.
So slow and so bad.
So you had to answer your exam papers in Chinese as well?
Yeah, I mean it's science, so it's.
Oh, you could use.
It was like fluid mechanics
stuff. So the temperature 会变.
Yeah, no, you don't have to write too much, right?
Yeah.
You don't have to write too much, and you can write some English when you don't.
Maybe equations.
Yeah, you don't have to. Like it's equations, it's math, right? So it's not that bad. But the books were in Chinese, so the first year was language, right? But you just learn how to speak and read and stuff. But exactly. It's not science, right?
Yeah.
And then I remember the first day I had a class, and then they give me the book. I was like, what is this? I don't understand anything because it's like engineering Chinese. And if I give my engineering book to a normal Chinese person, they don't understand what it is because it's all scientific terms, right? So I had to learn all the terminology. The fluid mechanics terminology in Chinese, but that was fast.
六体力学.
Yeah, 六体力学, all in Chinese, you know. And I was like, okay, I was actually fast. And the thing is, like, what I like with Chinese is like the way they describe things is so clear. It makes so much sense.
Yeah, that's right.
So I didn't think, like, when you know the terminology, it's not hard. It's not hard because the way they explain, it makes so much sense, you know.
Yeah, because Chinese has just so many terms.
Yes.
That tell you specifically.
Exactly. It's
what
very specific. So it makes so much sense. And then was very happy. But the first exam I remember took me so long to write in Chinese and read. And then like all the classmates were gone, you know, and I was alone. And the professor was like, oh, okay, so because I was the only foreigner, so it's like, I understand it's so slow and stuff. So he was like, okay, you know what? I'm gonna go back to my office. Just take your time. I leave at 5. So before 5, just swing by my office and just drop your exam paper in my office. I was like, oh, thank you. And I took the whole day. I just did my test like this, you know, slowly.
But did you know how to write all of those characters?
Yeah, most of them, yeah.
Oh my.
No, but and when you don't know, you know, you have it in your book somewhere because it's open.
So it was open book.
Always, yeah.
Oh, that's great.
Like sometimes it was closed book, but like closed book maybe for math.
Yeah.
Maybe for math.
Oh, for equations and derive some stuff.
Yeah. So
So what was your thesis for your master's or what
my thesis was about like
was it fluid mechanics as well?
Yeah. So my thesis, I invented a wind turbine. Yeah. A wind turbine. I invented a new type of wind turbine, and I have a patent for this one actually.
Oh, you really?
Yeah.
What type of turbine is it?
So it's like, you know, most wind turbines is like those huge rotors, right?
Yeah.
So it's like airfoils, right? It's like it works on lift. It's like when you have an airfoil, it's a lift. And I made a model of a drag wind turbine. Like, you know, the difference like a drag is like, okay, so when you have an airfoil, the airfoil is like placed parallel to the flow, right?
Yeah.
So like a part of the flow goes below and some goes above, right? Above. And it creates lift because the flow above is faster than below, so there's a pressure difference. Yeah. So it lifts, right? So it creates a force. Okay.
Like in the airplane.
Exactly. Right? It's the same principle as an airplane.
Yeah.
Like a rotor of wind turbine is like the exact opposite as a helicopter.
Yeah.
Helicopter, you have a motor that makes it turn, and then it creates lift, so it goes up.
Right.
But like with wind, the wind blows and it creates lifts, and so it makes it spin, right? Yeah. So when you have a drag turbine, it's like a sail on a boat.
Okay.
It's like you have a surface perpendicular to the flow.
Okay.
And so the flow impinges on the surface. so the flow hits the surface, impinges on the surface, and it pushes it.
Yeah.
Right? It's just the same as a sail for a sailboat, right?
How did you took it into a turbine?
So what I use is I use like a concave kind of like it's like half tubes. You have a tube,
Yeah.
and you cut it in half.
Yeah.
So it's called a Savonius turbine. It's like when you have like 2 tubes, and it's like
this.
like a spoon, right? You have like a spoon. You have like a concave side and convex side, right? So when the flows in, it pushes right on that side, and you place it's on an axis, so it spins, right? So there's one side with a bigger drag coefficient, and another side with a lower drag coefficient. So when it hits here, it spins like this, right? It rotates, yeah. So I modified this, and I put like instead of having 2 half tubes, I use 6 half tubes.
6 half tubes.
Yes, 6 like arranged like around. I can show you a picture like if you want to see. Yeah, so it's better. You can understand better.
We take a pause.
Okay, so I found the pictures.
Yeah.
So just show
Margot,
you.
if you want, we are prepared.
Oh,
we
wow.
can use
Awesome. Oh, thank you.
if you want.
A whiteboard. That's perfect.
Ta-da!
Nice.
Like a magician.
Okay. So exactly what I was
I will
saying.
be looking at it as well.
Okay. So what I was saying is a drag turbine is like, so like you have the blades is like the shape of a half tube, right?
Yeah.
So, and the axis is here, right, at the center, and then here.
There's another one.
That's the basic. So when the wind comes here, it blows here, right? And because of the distance from the center here,
it makes some
radius.
torque and makes it.
Yeah, exactly. So it makes torque here. And then here you have like less, this is more drag, you get more drag here than there, right?
Yeah.
So you have like there's a force difference, so you have torque, right?
Yeah.
So here you have like a smaller like drag, and here you have more drag, right?
Bigger one.
So that's why it makes the rotor spin, you know? So you spin like this.
Because some of the air that is flowing here, it will go this direction.
Yeah,
and
it flows at the same time
sorry.
in both, right?
Yeah.
So you have like the rotor is like this. So so it flows at the same time on both. So you get more drag here than there. So it spins. But like the problem in this design is like, if can I?
Sure. Okay,
yeah, I need
wait.
it. Okay, so the problem with this design is that,
Sorry.
let's say when you have wind like this, right?
Yeah.
So it's not gonna start because wind just blows over.
Oh
right?
yeah.
So it's not gonna move.
So you need 2 more.
Yeah. So that's why you put more blades.
Yeah.
So some people put like 4. You know, like you have like 4, like this, right?
Yeah.
So now when wind blows here, you get here. So you start, right? You can start. So me, like I designed it with like 6 blades. Because
It would be like hexagonal, right?
Yeah, exactly. But so what I did is like at the center I had like,
My drawing is so bad.
so I had like 1, 2,
Let me erase that.
3, 4, 5, maybe 6. I didn't do it
Somewhere
well.
there.
Yeah.
We engineers, not drawers.
Yeah, exactly. So 6, right? You have 6
Yeah.
blades. So when the flow is coming here, you get a little bit here, and then it goes in there, you know, and then you get here some flow here. So you get torque.
So it's a wind turbine that would work perpendicularly.
Yeah, it's perpendicular to
It's
the flow.
not. No. How do you say?
Yeah, so like it stands upright like this, right? It's just like you see it from the side. So let's say you have a house. Here's a house. You have a house, you know, with like people.
Okay.
Yeah, and then so wind blows here, right? And then it spins like this, right?
Yeah.
You know what I mean?
Oh, so this type of blade actually would be able to put in a house.
No, like you could see, like this is good for like
in buildings.
exactly. So this is good for like in cities, because like in a city like okay, so like wind, like
It's okay without driving.
so here, like if it's like countryside or the sea, like you have like boundary layer, like that's wind distribution, right?
Yeah.
That's wind, right? That's the wind speed. But when you get city, there's buildings, right?
Yeah.
So like
The
the
taller,
wind,
the better.
yeah, no, the wind distribution is chaotic. You don't get like nice, like streamlined wind. You get like chaotic. It's like a lot of vortices. It's really chaotic. So you cannot use like those classic wind turbines with like those rotors here, like those big wind turbines that you see on wind farms. You cannot use them because it's like too chaotic. Like the flow is like turbulent. It's too chaotic. You know, that's why it's good to use drag wind turbines there, because drag turbines, they don't care about the direction of the wind. They can take wind from any direction.
And like you just made the beautiful drawing. So out of this chaotic wind, could you take like with the turbine that you designed, could you still take the energy from this chaotic wind?
Exactly, yes, you can, because that's the point of a drag turbine. Is like it doesn't need like a clean, like uniform flow. Like, because when you see the huge offshore wind turbines, like in the sea or the wind farm, they have a huge, like they have like really like uniform, smooth flow, because they go from like it's on like it's on the sea, or it's on like a huge like grasslands. So when there's no buildings, so they get a uniform smooth flow. But like drag turbines, they can take wind from any direction. They can take wind from any direction. They can use like this turbulent, chaotic wind, just to rotate. You know, so that's the point. They have like lower efficiency. But they can take wind from any direction.
That's a great part.
So that's why they use for like industry, like urban environments. So inside the cities, you can see them in Taiwan, like at the street lights. You can see them. That's
right.
Yes.
Many street lights, they have this type of blades.
Exactly. They have the spin. You can see them.
Is it your patent? The one that you sold today?
It's not mine. I wish it was, so I would have a lot of money, but it's not mine. No. It's like similar. It's similar design, but it's not mine, but it's similar. Yeah.
Oh, but that's very interesting.
Yep.
And that was your master's.
Oh, yeah, that's what for my master's
your
thesis.
master's main topic.
Yeah. So I worked on that wind turbine. So I built a prototype. We did experiments, and I used numerical modeling. Yeah, to do the design as well.
And then, how was your change from master's degree to your PhD?
Oh, wow.
This is something incredible that when I find out that you were an MMA fighter as a hobby, and then you had also studied a PhD, and you are a researcher right now in Academia Sinica.
Yeah, actually, you know, like, I think it's easier when you're a student, you can train. Because like when you work, like when you're a student, you can make your own schedule, right?
Yeah, that's right.
And when you work as a researcher, you can also make your own schedule, because research, you know, is not about clock in, clock out. It's like, if you find out something good, then you have a great day. You're done for the day, you know? It's like, it's not about, you clock in and how many hours and then you're going to get something out. Sometimes you go to the lab for like days and you don't get anything, right?
Yeah, right.
Sometimes you just like, yes, you have an idea. Hey, it works out. And then it's just in a little bit of time, a little amount of time, you can get something great. So, and also like the thing I like is the flexibility of the schedule, like with research. You make your own schedule. You do it on your own time. Yeah. So that's how I can train. Because if I had a job where I had to do 9 to 5, it's really hard to get training, because the body, like you train when
you need rest.
You need rest, and also like there's hours for training. You train best during the daytime, and that's why martial school they like at night you're not supposed to work out. You're not even supposed to work out at night. Like human, you're supposed to work out in daylight.
Yeah.
Right? So during the day, late morning, early afternoon, that's where you perform the best. So that's when the training should, like, so that's what I do. I train either in the morning, either in the afternoon, and I do research in the evening, in the morning or afternoon, depending on my training. So actually, like, studying and doing research, is what allows me to train that much. Like if I had a job, a 9-to-5 job, I couldn't be training that much, you know.
And like you just mentioned, in the daylight should be the trainings.
Yeah.
How about the fights? Most of the fights are at night.
Oh yeah, that's tricky. You know what? I'm going to tell you something you probably don't know. You know, like because of the lighting in the stadium when you fight, you don't see the punches that much because of the bright lights.
Oh really?
Sometimes you have the bright lights in your face, you know, like from because the lighting for the cameras, right?
Yeah. The cameras.
So when the guy punches you, sometimes you don't see the punches as well. So like
when you are looking upwards, right? You have all these lights.
Yeah, you have when you fight, even when you're looking at the guy, and when he throws a punch, you don't see as good as what you see in training. So high level guys, they bring those lights in the training. They bring they buy those huge lights, and they when they spar, they turn those lights on. So they mimic the same environment. They turn off the light and they use the
That's very intelligent. That's very intelligent.
So they get used to.
Yeah,
because that's tricky, man. Like the first time I fought was like, you don't see the punches as well. You know, I was like, the first time I fight professionally, I was like, whoa.
But you won. So
no, I won, but like because I could take the guy down. Yeah, otherwise I would have got my ass kicked. No, man, no, but like, no. I mean, training is like daytime is when your body feels better for training, like up to early evening. You know, the worst thing they do with tournaments. I don't know if you have done many tournaments, but really. They start in the morning, and you feel like shit in the morning, right? You feel so tired, right? When they start competition at 8 a.m., right, and you have to go. You're like when you go at 8 a.m. and then you say, oh, you're on the bracket. Then you have 8:30 a.m. You have to start giving you know, because like, you actually feel good, like physically. Like I think afternoon, like, right? I think that's the best time for training. Like
in the
midday or afternoon. Yeah. So that's what I mean. Like in the evening, you should be like resting or like using your brain. Or I don't know.
Manu, going back a little bit to your PhD.
Yeah, sorry.
Because, no, it's okay. I
get carried away. Yeah.
We both like a lot. Like
sports is fun.
Yeah. But going a little bit back to your PhD and your work as a researcher.
Yeah.
I saw that you posted about your thesis, that it's about vortex.
Induced
vibrations. Yeah. What are these vibrations? Flexible cantilevers, right?
Okay.
Or something like that.
Yeah, so that's a very interesting topic. So, like I said, like I really like fluid mechanics, but what I like most is like I like interdisciplinary like topics. Yeah. When you have like more disciplines, they coming together, because like I didn't want to do a PhD on like pure fluid mechanics.
Yeah.
So I wanted to do something which involved like a vortex-induced vibration is like a mixture between fluid mechanics and vibration, structural vibration.
You just mentioned like the wind it's a fluid as well.
Yes. So like the thing, like when you have flow around like bluff bodies, you have like vortices, they generate vortices, right? And when you have these vortices, they generate at a certain frequency. You know, and like when you generate vortice, like it changes the force acting on the body, and like if you have like at a certain frequency, the vortices are shed, so the force is like oscillating, you know, at the same frequency as the vortice. So there's like oscillating excitation on the body. Yeah. So it creates vibration. You know, and there's this example is like the Tacoma Bridge is a very famous example.
The Tacoma Bridge,
yeah. So
the one that fall down.
Exactly. Yeah. Because of the vibration and the vortex shedding frequency was at the same frequency as the natural frequency of the bridge. So the aeroelastic force was at the same frequency as the natural frequency of the bridge. So you get this vibration that cannot be damped. There's no damping in it, so it gets bigger and bigger and bigger, and then the bridge collapses.
Yeah.
So like vortex induced vibration, you see it also on buildings. Like when you have like tall skyscrapers, there's wind flowing around buildings, right? And you can see buildings like swaying in the wind. Yeah, they move. Yeah, so there's a lot of application. You see it in like turbines, fluid machinery. When you spin, you create vibration of the blades, and also like a flutter, like airplanes. Yeah. Like they had like airplanes crashing when they figure out when they had like jet fighters in the 50s. They have like they started experimenting with jet fighters. Like they were going really fast, and they had like the wings would start vibrating so much. And they had like a lot of plane crashes, and they didn't figure. I said, why? What's happening? And that was flutter. Like at a certain speed, the airfoil start like vibrating the flap.
But
so
it
much.
Depends also a lot in the material, right?
Yeah, because it's a mixture between fluid dynamics and solid dynamics. So it depends on the stiffness of the structure and the natural frequency of the structure. Yeah. So on the excitation is like the flow, the vortex shedding frequency, the frequency at which you shed vortice in the wake, and the response on the structure is like the natural frequency of the structure, the stiffness. Yeah. So it's very interesting. It's a mixture between vibration and fluid mechanics. So that's why I chose that topic. And
right now in Sinica, what is your research about?
Okay, so
is it also
I always love renewable energy. So master's degree, I did this thesis on a wind turbine, right? Wind turbine. And my PhD I did on flow-induced vibration, but I did it for energy harvesting. So I use this vibration that is generated by the flow, by the vortice.
Yeah.
I use the vibration of the structure. If you use PVDF or PZT, like piezoelectric material, you can actually from the vibration you can get electricity.
Yeah.
So you can use that. We can use that those vibration that was the vibration that were harmful, that would destroy the structure. We use it to make vibration that actually you can make electricity out of those vibrations. And this is great for marine energy. You could put it in the ocean.
Yeah,
right? You could put it in rivers. Yeah, you could put it outside in the wind, so you can get energy from any fluid flow.
Any tide and the tides, right?
The tides, exactly. Currents in the ocean. You can use currents in the ocean. You can use the tide. You can use river. You can use wind. You can use anything. And so that's I always love renewable energy. That was my first passion was renewable energy. And I worked this project at Academia Sinica is so a lot of countries now 2050 they want to go zero emissions.
Yeah.
So because if we keep on the trend that we have now, global warming is going to be unacceptable. By 2050, it's going to be unacceptable. For the environment, the caps are melting.
Yeah.
And so. But
2050, isn't it too far away for a goal like that?
No, there are different goals. There's a goal for 2030 to reduce half the emissions.
Oh, that's already a lot.
That's already a lot. It's 10 years from now, half the emissions. Imagine. So because to keep emissions below, because from the beginning of the industrial era up to now, we have to keep the global warming to 2 degrees. That's the goal.
Yeah.
So there was a conference in Paris that a lot of countries signed. The Paris conference.
The Paris Agreement.
Paris Agreement, the objective is to, by 2030, 55% of emissions. By 2050, 100%, right? So net zero. And then we can keep global warming below 1.5 or 2 degrees Celsius. So,
but Manu, right now the emissions aren't them exponential? So decreasing them by half, wouldn't it be still a lot? Or is it a linear one?
No, okay. So this is actually it's feasible. So what's happening? We have emissions from transport, right?
Yeah.
energy production, right?
Yeah.
And industry.
Yeah.
That's like the three sectors we have, right? Emissions for like so electricity.
Mainly.
Yeah, mostly, right? So like emissions, we can lower them. Like I'm working on a scenario that shows that we can use wind, we can use solar, we can use geothermal, like for Taiwan. So we can have like no emissions for electricity production.
For electricity?
Yeah, so you can have almost zero emissions for electricity production. So you have like 100% clean energy.
I mean, if it's 10%, it's still a lot.
Yeah, but the problem is like it's a political problem though, because then the electricity price is gonna be 3 times what it is now.
Oh, so
2 or 3 times more expensive to pay for electricity, and then like the industry, they can lower the emissions by using obviously more efficient process, but mostly there's one thing that needs to be developed is like carbon capture technologies, right? Yeah. So if they implement carbon capture technologies in the industry, then they can lower the emissions. And then the transportation sector. Yeah. So if you have like clean electricity, then you can use electrical vehicles. Yeah. You can also you can also use biofuels. You can use,
because right now many people are celebrating like, hey, we're using electrical.
It's so stupid.
Yeah.
Because the
electricity
comes from coal in this country, which is the dirtiest form of electricity. Yeah. It's so stupid.
Like,
it doesn't make any sense.
From my point of view, it's senseless.
It doesn't make. It's even worse. You create more pollution. So.
But of course, there are some companies that are like, okay, we know about the carbon, but we're gonna develop solar for this electricity.
Then it makes sense. There. So like, if you you can use biofuels. Yeah. Biogas. So you can reduce emissions in each sector, but like it's very hard to go to net zero. But for net zero, you need carbon sinks. So you need to capture the carbon, or you need to plant trees.
And it's also right now we cannot reduce it's gonna be hard to reduce the emissions. So we need to improve the capturing.
Like it's both ways. Like we need to stop emissions, and we need to capture. So because like for example, like coal needs to stop. Like all the coal plants need to be dismantled completely. Like wind, solar, geothermal, 100% clean electricity. That's the first thing for this country. So when you have 100% clean electricity, then with this you can lower already 60% of emission.
Really?
Yes.
Only by electricity.
Exactly. But the price, like I said, is going to be 2-3 times the price of electricity now. So then how does the industry respond to that? So like, because the industry, if they have to pay 2-3 more times the price for electricity, what's going to be the impact? So it's a political question too. And then industry, you tell them, no, you have to use carbon capture. And say, oh, but it's expensive. And then the products become too expensive, and we can sell products. So, like, actually, it's totally feasible. It's doable, but it's like...
And that's what you're working on.
So what I'm working on, I just make... Because I'm a scientist, I'm not a politician. So I make a scenario that...
And you show it.
That shows that, hey, it's completely possible. Like, for my calculation now, like, only electricity sector is already 60%. And then...
It's incredible.
You can also, like, go work on the industry and transport. I think you can get to 80% emission reduction easily. But again...
That's going to be a huge step.
Yeah, and yes, and then if, like, the problem is, like, all the countries have to do it too. Because, like, it's a small country, right? Yeah. I mean, it's a small place, right? So if you have, like, bigger countries and they don't do it, when you have, like, a small country that does it, but you have bigger countries around that don't do it.
Yeah, that's right.
Yeah, so like everybody has to do it at the same time. So it's like it's a political issue, but because the science is here, it's possible to do it. It's possible to have like almost zero pollution.
Yeah, like it's like you want to be standing with only one leg, right?
Exactly. Yeah, no, it's totally possible, but it's like it's a political decision. scientifically it's feasible, completely feasible. Yeah.
Well, Manu, what would you like to say as a conclusion? Do you have any fights coming?
No, it's like pandemic. There's nothing like, but like.
You getting the vaccine?
I think so. I want to get vaccine. I heard like it's available now, right?
Yeah, that's right.
That's why. So I want to get it. No, like because I can't wait to be traveling again, and yeah.
Well, what is the next destination for Manu?
I'm not sure. Like, I may go home for a while.
Oh, that's good.
Yeah,
Incredible.
I may go home for a while.
I want to go back home too.
Yeah. It's far. It's far from here, right? The flights, it's expensive flights, right?
Right now, the flights are very expensive.
Yeah, very expensive, I guess.
Yeah, well,
how long have you been away from home?
2 years, more or less 2 years. But it's the most I've ever been.
Yeah, that's too long.
So yeah.
Yeah.
Well, Manu,
thank you so
much.
much.
Thank you very much for coming.
Thank
for
you.
sharing all your knowledge, all your experience.
Not much.
It was an incredible time. Thank you very much.
Thank you so much. Thank you for having me.
See you next
Thank
time.
you so much. Thank you. Awesome. That was fun. Thank you so much.
Great. Thank you very much for watching this episode. Like the video in case you liked it, and leave a comment below for further improvement of our content. As well, if you like topics such as new technologies, research done in universities, or even wonderful stories of incredible people, subscribe to our channel. This is how you find us in social media. I want to give a special thanks to all my sponsors and team members. Y recuerda, toma pulque y come nopal, que la próxima semana otro video se va a lanzar.